Hey, welcome. We're surrounded by data every single day, from the news we read to the ads that pop up on our phones. But how do we turn all that noise into something that actually makes sense? Well, that's what we're going to do here. We're going to break down the basic tools of statistics so you can find the real story hidden inside the numbers. Let's just jump right in with a whopper of a number. $2.5 million. Now, that's what it cost on average for just one 30-second commercial during the Super Bowl way back in 2006. Think about that. That's not just a random figure, it's a piece of data that tells a huge story about advertising, about economics, and even about our culture.
And it's not always about giant, multi-million-dollar deals. Here's another one, 31%. A study found that nearly a third of adult men watch 10 or more hours of TV every single week. See? Just like the Super Bowl ad cost, this little statistic gives us a snapshot of everyday life.
So we've got these numbers floating all around us, from massive business deals to our own habits. The big question is, how do we make sense of it all? How do we take these raw figures and turn them into something meaningful, something we can actually use? Well, that is the power of statistics, and that's what we're going to dive into.
Because the truth is, statistics are absolutely everywhere. They're the tools we use to turn chaos into clarity, to find those crucial insights that really drive the world around us.
And listen, this is not just some boring academic exercise. Out in the real world, in finance, marketing, you name it, being able to understand and use statistical information is what really sets the most successful people apart. It's all about making smarter, better informed decisions.
Okay, so if we're going to make those smarter decisions, we need to get the fundamentals down first. So let's start by looking at the anatomy of a data set. We're going to break down the essential building blocks, the basic language of statistics.
We're going to use this table right here as our guide. It shows data for 25 different companies from the S&P 500. Think of this as our case file for today. It's going to help us nail down some really important terms. All right, first up, the most basic word of all, data. What is it? Simply put, data is all the facts and figures you see right here. It's the raw material, the clues. Everything in this table, from a company's name to its share price, is data. Now, to start making sense of all this data, we first have to identify the elements. This sounds a little technical, but it's super simple. The elements are just the subjects we're studying. So in our table, each individual company, like Abbott Labs or eBay, is an element. Next, for each of those elements, for each company, we're collecting info on different variables. A variable is just a characteristic we're interested in. Just think of them as the columns in our table. What stock exchange is the company on? What's its share price? What are its earnings? Each of those is a different variable. And when you put it all together for one single element, you get what's called an observation. So that entire row for Altria Group, its exchange, its ticker, its share price, all of it, that whole line of data is one complete observation. Simple, right?
Okay, so now that we have our basic building blocks, it's time for a really key idea. Not all data is created equal. The type of data you're working with is so important because it totally changes the kinds of questions you can ask and, well, the answers you can get.
The biggest split is between qualitative and quantitative data. Qualitative data is all about descriptions, labels, names, categories. In our table, the exchange is qualitative. A company is either on the NYSE or the NQ. Quantitative data, on the other hand, is all about numbers. It tells you how much or how many. The share price, that's a perfect example of quantitative data.
And we can get even more specific with these 4 scales of measurement. Now, don't get bogged down in the details here. The key takeaway is this. As we move up the ladder from simple categories like nominal to something like ratio, which is a true 0 point, our data gets way more powerful, and the kind of analysis we can do gets much, much cooler.
And this is a perfect way to see another key distinction. On the left, our S&P 500 data is cross-sectional. It's a snapshot, a photo of 25 different companies at one single moment in time. But on the right, that gasoline price chart, that's time series data. It tells the story of one thing over a long period of time. So one is a photo, the other is a movie.
So now that we have the language to describe our data, what do we actually do with it? This is where we meet the 2 big families of statistics, describing the world we can see and predicting the world we can't.
First up, we have descriptive statistics. The name kind of gives it away, right? This is all about summarizing the data you have in a really clear, easy-to-understand way. This bar chart, for example, takes that exchange variable from our table and instantly, visually, shows us that 80% of the companies in our set are on the New York Stock Exchange. So, descriptive statistics, whether you're using a table, a graph, or just a simple average, it's all about one thing: presenting the facts you've collected as clearly as possible. No guesswork, no jumping to conclusions, just the facts.
But what if we want to go beyond the data we have right in front of us? What if we want to say something about a much, much bigger group? Well, this is where the real magic of statistics happens. This is where things get really cool.
And this is the world of statistical inference. Look, we often want to know something about a huge group, a population, but it's usually impossible or just way too expensive to study every single member. So what do? We take a small piece, a sample, we study that piece really carefully, and then we use what we learned to make an educated guess about the whole thing.
To pull this off, we just need two more key terms. The population is the entire group we're interested in, the whole shebang. For instance, all the light bulbs a company ever made. Since we can't possibly test every single one, we take a sample, which is just a smaller, manageable subset, like, say, the 200 light bulbs we can actually test in a lab.
And this right here is the heart of inference. This is the secret sauce. We take the data from our sample, like the average lifetime of those 200 light bulbs, and we use it to estimate something about the entire population. We use what we know about the few to make a really smart, educated guess about the many. And that is how we make predictions and decisions with confidence, even when we don't have all the information.
Which brings us to this fantastic summary of everything we've talked about. Statistics is the art and science of collecting, analyzing, presenting, and interpreting data. That just nails it, doesn't it? It covers the whole process, from collecting the raw facts, to presenting them clearly with descriptive stats, all the way to interpreting them to make powerful predictions using inference. So there you have it, the fundamental building blocks, the basic toolkit for making sense of the numbers all around us. We've seen how to describe the world as it is, and we've seen how to make educated guesses about the things we can't see. So the only question left is, now that you have the tools, what story are you going to find in the data? Thanks for watching.